Hello students, my name is Gagana Ma'am. Welcome to AskPrep. I'll be teaching the first chapter of class 11 in detail. If you have any doubts, please feel free to ask in the comments. Let's get started. So in the previous class we discussed about international system of units. I'll continue with the further. So the basic physical quantity is length. The symbol for length is L. Name of the SI unit is meter. Symbol of SI unit is M. Mass. Symbol for quantity is M. Name of the SI unit is kilogram. Symbol of SI unit is kg. Base physical quantity is time. Symbol for quantity is T. Name of the SI unit is second and symbol is S. Electric current, the symbol is I. Name of the SI unit is ampere. Symbol of SI unit is A. So thermodynamic temperature, symbol for quantity is T. Name of the SI unit is Kelvin and symbol for SI unit is K. Amount of substance, symbol for quantity is N. Name of SI unit is mole. The symbol of SI unit is MOL, mole. Base physical quantity is luminous intensity. Symbol for quantity is IV. Name of the SI unit is candela. And the symbol for SI unit is Ct. So definitions, we have to study about these physical quantities. Unit of length, how is it defined? It is meter. The meter is the length of the path travelled by light in vacuum during a time interval of 1 by, it is around 2,99,79,024 of a second. Unit of mass is kilogram. The kilogram is the unit of mass. It is equal to the mass of the international prototype of the kilogram. Unit of time, second. The second is the duration of, it is around 9 lakh, it is around so much 77 periods of the radiation corresponding to the transition between the two high profile levels of the ground state of the cesium-133 atom. So unit of amount substance is mole. Mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon-12. Its symbol is mole. So when mole is used, the elementary entities as must be specified and may be atoms, molecules, ions or electrons, other particles or specified groups of such particles. Unit of luminous intensity is candela. Candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 power 12 Hz and the radiation intensity in that direction is 1 by 684 steradian. So the next is unit of electric current, ampere. Ampere is that constant current which, if maintained in two straight parallel conductors of infinite length of a negligible circular cross section and placed 1 meter apart in vacuum, would produce between these two conductors a force equal to 2 into 10 power minus 7 Newton per meter. So if you place any wire between these, the current, if you take a long wire, so it would produce a force equal to 2 into 10 power minus 7 Newton per meter. So unit of thermodynamic temperature is Kelvin. So Kelvin is the fraction, that is 1 by 273.16 of the thermodynamic temperature, which is the triple point of water, which is also known as triple point of water. So these are the different symbols which is used to represent the units in terms of powers of tens. 10 power minus 2 is centi, the prefix is centi and the symbol is C. 10 power minus 1 deci, symbol is D. 10, the prefix is deca, Da, the symbol. 10 power 2, the prefix is hecto, the symbol is H. 10 power 3, the prefix is kilo, symbol is K. 10 power 6, the prefix is mega, symbol is M. 10 power 9, the prefix is giga and the symbol is G. So 10 power 12, the prefix is tera, symbol is T, capital T. So the next one is 10 power minus 24. It is in minus. So yocto Y. 10 power minus 21. It is zepto Z. 10 power minus 18. It is atto A. 10 power minus 15. It is femto F. 10 power minus 12. It is pico P. 10 power minus 9. It is nano N. 10 power minus 6. It is micro mu. 10 power minus 3. It is milli M. 10 power 15 it is peta P, 10 power 18 it is hexa E, 10 power 21 it is zeta Z, 10 power 24 it is iota Y. So the next is dimensional analysis. So while calculating we need to convert units from one system to another. So this method is called dimensional analysis and this is called factor label method or unit factor method or dimensional analysis. So the next quantity, measurable quantity is mass and weight. So what is mass? Mass of a substance is the amount of matter present in it. So how much matter is present in that, that is the mass. Whereas weight is the force exerted by gravity on an object. So what is the force exerted by the gravity? That is the weight. So mass of the substance is constant, whereas its weight may vary from one place to another. So mass is always constant, but weight is vary with respect to the change in the place. So the SI unit of mass is kg, that is 1 kg is equals to 1000 grams. Generally it is used in laboratories. So volume. So volume is the amount of space occupied by a substance. It has units of length cube. 1 liter is equals to 1000 ml. So 1000 centimeter cube is equals to 1 decimeter cube. For smaller volumes, it is denoted in centimeter cube or decimeter cube. A common unit liter, which is not an SI unit, is used for measurement of volumes of liquids. So the next is density. Density is equals to mass by volume. So it is the amount of mass per unit volume. So SI unit of density is kg per meter cube. So density is also expressed in gram per centimeter cube. Temperature. So there are majorly three common scales which are used to measure the temperature. Degree centigrade, degree Fahrenheit and Kelvin scale. Degree Fahrenheit is related to degree centigrade as degree Fahrenheit is 9 by 5, degree centigrade plus 32. Kelvin scale is related to Celsius as degree centigrade plus 273.15 degree centigrade. Okay. So the next concept is scientific notation. So it is used to deal with extremely large numbers or small numbers. So these are the major is used to the scientific notations with extremely large or extremely small. Scientific notations are n into 10 power n. So this is a formula which is used to calculate or to deal with the larger numbers, where n is the digit term. Digit term in the sense how much digits are present. It varies between 1.000 and 9.999. So n is the exponent having plus or minus. It depends upon positive value or negative value. So speed of the light is 3 crore meter per second. So in scientific notation we are using to represent this is the extremely large number. So we have to convert this into smaller convenient way to represent, and it should be easily understandable. So 3 into 10 power 8 meter per second. So the next is addition. So numbers are written we have to write the numbers in the way that they have the same exponent. The coefficient must be added or subtracted. So addition of 6.625 into 10 power 4 and 8.95. So we have to first shift the zeros to the left hand side so that we can make all the exponents as same. So 10 power, here it is 10 power 4, 10 power 3, we have to make it as 10 power 4 and we have to add. So if we shift the decimal points to the left hand side, you get the above value. So the next is subtraction. Example, it is the same. We have to make the exponent same. So 2.5 to 10 power minus 2. So we have to change the exponent value. As it is same, there is no need to change the exponent value. 10 power minus 2 and minus 2. You have to just subtract and you get this 2.02 into 10 power minus 2. So the next is multiplication. So this also has the same rules for the exponential, but in multiplication exponents are to be added. So 5.6 into 10 power 5, 6.9 into 10 power 8, grouping the exponents to one side, 10 to the power of 5 plus 8. You have to add these exponents. You get these value after multiplying the remaining digits. So if you shift the digit to the left hand side, so it will become a smaller, we have to convert it into a smaller value. So 38 is larger compared to 3.8. So 3.8 into 10 power 14. So division is also the same. You have to subtract the exponents here. In multiplication you have to add. In division you need to subtract. 2.7 by 5.5, that is 10 power minus 7. You get this value. So the next is significant figures. So what are significant figures? So these are the meaningful digits which are known with certainty. So if significant figures, they have some significance. So they have some certainty. So if the value is precise, if you say anything, any number is precise, it should be exactly equal to the near value. Accurate means exact value. So in measurements and all, if it is near value, we say it is precise. If it is exact value, we say accurate measurements. So what is the importance of significant figures? Why do we need significant figures? See, the uncertainty in the experimental or calculated values are indicated by significant figures. So with the help of significant figures, we do the experimental or calculation value. So by see, this is accurate and precise. See, all the arrow which is the pointing towards the archer board, it is the same. Accurate, precise. This is precise. It is not reaching the middle point, but not accurate. It is precise. It is nearer, but not exactly on the same point. But here it is neither accurate nor precise. So example, if the true value is 2 gram, from these three, which is accurate? I mean, we have to calculate which is accurate and precise from the following example. So if the student A measures the value 1.95 and 1.93, student B 1.94 and 2.05, student C measures the value 2.01 and 1.99. So how much do we get? And the correct nearer and accurate pressure value, precise value is student C. So if the true value is 2 gram, 2.01 is a little accurate. It is nearer. 1.99 is near. It is precise. So we can conclude from this. So the next is rules for determining the number of significant figures. All non-zero digits are significant figures. So all the non-zero digits, like in 285 centimeter, there are 3 significant figures. So if there are no zeros, then all the numbers are significant. So zeros preceding to first non-zero digits are not significant figures. So if there are zeros before the digits, then it is not significant. 0.03 has one significant figure and 0.0052 has two significant figures. So you should not count the zeros. Zeros between two non-zero. So before the digits it is not significant, but in between the digits it is significant. So 2.005 has 4 significant figures. Zeros at the end or right of a number are significant provided they are on the right side of the decimal point. So if there is a right side on the decimal point, they are also significant figures. If a number ends in zeros, that are not to the right of a decimal, the zeros may or may not be. So if it is to the right, it may or may not be significant. See, 14,400 gram may have 2, 3 or 4 significant figures. So we cannot conclude if it is on the right. So what we have to do, there's some confusion in this. So this confusion is generally identified by the scientific notation, that is n into 10 power n. N is the significant figure. So therefore 14 into 10 power 2 has 2 significant figures. So you are grouping the zeros or the tens numbers in one side. So this is zeros. So 10 as there is 2 zeros, 10 power 2 has only 2 significant figures, 14 into 10 power 2.